So now we have to move on to our next speaker.
Thank you.
So next up is Chris Lintott. Chris is a professor of astrophysics at Oxford University, where he does a lot of citizen science projects, and is also well known for appearing on BBC's The Sky at Night. But more relevant to this conference in particular, he's one of the editors of the AAS journals, in particular with the software and data aspects, and the editor of the research notes of the AAS. So he's going to tell us a bit about how journals are involved in reproducibility and open science. Take it away, Chris.
Thank you very much. Let me see if I can successfully share a screen. Let's hope so. Screen, hang on 2 seconds. Desktop 1, there you go, share. Do that. Hopefully you're now seeing my slides. Please let me know if you're seeing anything else. Thank you very much for inviting me to be part of this conference, and thank you for that fabulous opening talk as well. I want to start with my standard disclaimer whenever saying anything about publishing, which I think is something that dates back to the first journal published in the 17th century, which is that if you have n scientists in a room, there are at least n, and likely a number greater than n, opinions about how scientific publishing works, should work, and is working. And so I'm only going to present my own view, and I'm going to try and not make it an advert for what we do at the AAS. There'll be no subliminal messaging about where you should publish during the rest of this talk. But in thinking about what I was going to talk about, I realized there's a sort of standard talk that I've given myself to conferences like this one aimed at encouraging open and reproducible science when we get near talking about publishing. It's something that came up a lot in the early years of the Astronomy conference, which I helped organize, for example. And it starts with a simple thought, which is that open access or open science in general is good for lots of the reasons that we've just heard about, that it's just fundamentally, in some sense, a moral thing as well as an accelerant for our science if the science that we do is open and accessible to all, particularly those who pay through it through their taxes. And from that, you get the idea that we need more open access. And then that leads pretty quickly to thought 2, which is, blimey, journals are expensive. And particularly, even though we have moves towards more open access through initiatives like Plan S and the groups of funders who are putting together money and putting their money behind the idea that we must publish in open access journals. Sorry, I know I've lost my screen. There we go. You know, the requirements on individual authors to pay are increasing, or at least individual authors' institutions to pay, rather than being hidden in the library budget. The funding to publish in an open access journal tends to be something that devolves to individual researchers or research groups. And so this creates general anger, which I share, about some of the scientific publishing ecosystem. And there's a long-standing boycott of Elsevier, for example, who get held up as the worst of the worst, and people point to a profit margin which is somewhere between about 25 and 40% profit from their journals. And people look at things like Nature's recently announced open access policy, where up to €9,500 is the fee for making your Nature paper open access, or some of the Nature staples. And there are all sorts of caveats and things around that, but you can see why people in talks like this get angry and decide that the thing to do is to have a revolution and to overthrow the publishing system in favor of something that's more equitable, cheaper, and real. Again, I've been there and done this. And that conversation usually goes along the standard form as well. We say, well, look, we share our science on archive, in particular in astronomy. Where you are in our various subfields might influence how you use archive. Perhaps the cosmologists are happy to put stuff on archive the moment they've thought it, whereas when I used to work in star formation, it was the culture was to do so only after acceptance. But nonetheless, almost all the astronomical literature ends up on archive. So what are we paying these journals for anyway? And in general, across all fields, the number of papers on archive is growing rapidly. we're the red stripe in here. That's AstroPH's growth since 1991. And people have tried to build what are called overlay journals on top of arXiv. So the problem with just putting stuff on arXiv is that I sincerely believe there is some value in peer review. We'll come back to exactly what that is in a sec. But at least our institutions like us to, and our grant funders like us to have had peer-reviewed manuscripts. So people like Peter Coles, who's now at Maynooth, have built things like the Open Journal of Astrophysics, which you submit your paper to arXiv, you tell Peter you want it to be reviewed, and he does all the other functions of organizing reviewers and so on. I was actually involved in technical consultancy when Peter set this up, so I helped found this journal. And it's worked okay. There are a handful of papers each year published in OJA. I think there's an argument to be had, which I don't propose to have now, about how this model would cope if it became the main way of publishing. I think there are certainly some costs involved that aren't incurred by a few papers a year that would be incurred if it was publishing the 10,000 or so papers that Astronomy submits each year. But the interesting thing here is that only a few people have switched to this free service. So either journals are doing a brilliant job with the other bits of their job, like copy editing or providing exciting submission manuscripts or so on, or perhaps just marketing, or there's another problem, which means that people are looking to publish in legacy journals. And because we've just heard the previous talk, we know that what is, we want to get jobs, and those of us in jobs want our students to get jobs and perhaps even get promoted as well. And this has become tied up with the system of academic CVs that's based on publishing, or publish and perish, or whatever. And in particular, this advice that we just heard about, which was that what you have to do is publish in high impact journals. And usually that means, for many people, high impact means defined by the impact factor, which is, for any given year, the total citations obtained in that year for publications in the previous 2 years divided by the number of those publications. And so this measure, unfortunately, is almost completely uncorrelated with the quality of papers in a journal. At least you can't use it for any particular paper in a journal. So there's a couple of reasons for that. One is that the timescale is too short. My favorite example of this is Vicky's famous paper, which mentions dark matter. This is the citation history from the early 30s. When it was published, 37, basically no one cited it until people noticed in the 90s that it prefigured what we now thought of about dark matter and galaxy clusters and started citing it. But more usefully, perhaps, this is the percentage of papers which are in the top 50 cited articles N years after publication. And so what you can see is that it takes time. These curves go down. So by something like 10, 15 years after publication, only about a quarter of the papers that are in the top 50 most cited, those that have the biggest influence on impact factor, only 25% of them were the instant hits that were also included in those first couple of years. So it takes time for us to work out as a field which papers were truly insightful and useful and helpful and so on. The big hits are often wrong or turn out to have less long-lasting impact on the field. And so this advice to publish in high-impact journals is sort of negated by the fact that the impact factor doesn't tell us anything about the quality of paper. And as we've heard, the solution is that we have to have this revolution again. We have to change how academic promotion and job getting goes. And lots of people are working really hard to try and do that. I have huge respect, particularly for Dora, who have made, as we've heard, made this explicit suggestion that you shouldn't use impact factor. But I think this idea gets us rather stuck right now, because if we're as a small group of people gathered in an excellent, though restricted Zoom conference for a few days, it's not really in our power to alter the mode of academic promotion and achievement across our various institutions, continents, and countries. And so I think this route, and I've tried to do the standard talk in about 10 minutes, I think gets us pretty stuck in many cases. And I certainly found myself going to the same conferences with the same people, having the same rants, which is hugely productive and interesting, but not really working out what we could do to make changes. And the key to not just getting stuck in this loop is, I think, to realize so that yes, our system is poorly designed, but it seems like we're stuck, but we have a way out because of a couple of salient facts that apply particularly to our community. And so you can start with the thought that astronomy is just great and awesome and interesting and wonderful. This is the latest web calibration, sorry, JWST calibration picture compared to Spitzer, which is fab. But more than that, I think lots of us know that astronomy is weird. And I don't really mean that astronomy has weird things like penguin-shaped galaxies with conveniently placed eggs in our sky surveys. What I mean is that we're weird from a publishing point of view as well. We're weird in particular that the major journals, which publish most of the astronomical papers in the world, are society owned or operated, which means they belong to the communities, not to a commercial publisher like Elsevier. There are 4 or so journals of, you could argue about the order, and I'm supposed to argue about the order, but they're all roughly of equal standing, which means there isn't a clear hierarchy. So you don't do what people in other fields have to do, which is submit to a top journal, get rejected, work their way down until it gets accepted. And actually, all of these journals have pretty high acceptance rates. I think on average across them, it's about 85%. Most papers that get submitted to astronomy journals get improved by the peer review process, which is more of a collaboration with the reviewer rather than a gatekeeping function, and then accepted into one of those journals. That makes us deeply strange within science. And so lessons that come from elsewhere are slightly difficult to apply to our particular niche, but it also gives us advantages. Because these are society owned, we can have large amounts of influence on these journals. Because they have high acceptance rates, they're not competing with each other, particularly on impact factor. They clearly all care about that, which means that they can make changes to their publishing model. They're less worried about letting in things that may make big differences. And because they're competing with each other in ways that are other than hierarchy and prestige, they can actually do quite radical things to make changes. And so my contention, central contention of this talk is that once we realize that astronomy is weird, once we realize that while going to the barricades is fun and bringing down the system is definitely something we should spend some time thinking of, we can also make changes at this scale. And then we can make some progress towards greater open science and reproducibility. We also have, I just want to note in passing, that we also have the advantage of ADS, which doesn't exist in other fields. And ADS is a community-driven, centrally funded, responsive organization that keeps our bibliograph, that keeps track of citations and the relations of papers to each other, and which is used by almost everyone to discover papers, gives us a central advantage. I ran the ADS users group for years, and one of the librarians we had on the users group insisted on starting meetings by telling us that we did not know how lucky we were that this thing existed, because it allows us to do things like highlight various different forms of publication in the same place that people go looking for their papers. Other fields don't do that. They have to rely on commercial things like PubMed or Web of Science or on Google Scholar. So let me give you a concrete example of what I mean. When I joined the AAS journals, which happened to me after I was too loud at a meeting about reproducible research, so be careful, in 2016, this was the policy on software, or at least what passed on it. It had last been revised in the early 60s. And it explains, I won't make you read it all, but it explains that precepts for programming a method for automatic calculating machines, including such things as formulae for the numerical evaluation of functions, algorithms and computational precision, including programs written in universal languages like ALGOL or Fortran, all programs written in machine language, are of doubtful proprietary for the journal. They're not astronomical, though they may be imported tools, and a need to communicate these things is supplied by the Association of Users of Automatic Calculating Machines. The point is, this is out of date, and it doesn't reflect a world in which lots of us spend lots of our time writing software, and where we'd like the academic career structure to reward people who spend time writing good software that's used by the community. Now, one option is to develop an alt metric which includes software and perhaps to make promotion cases or job talks that involve a section on what software contributions you've made. But it's much easier, I think, to disguise software effort as normal journal papers. So we changed the policy. So we said, okay, if a piece of novel software is important to published research, so if it was used to create a paper, then it's likely appropriate to describe it in a software paper. So if you've used software to do your research, your software should be documented in the astronomical literature. And then those papers which describe the software can be short and descriptive. So the idea here is to make them easy to write, so that people can write a 2-page paper describing a software package that they've written and put it in the astrophysical journal or the astronomical journal, so that when it goes on their CV, they don't need to persuade the person funding them that they have put special effort into software. They can just say, look, I have a highly cited AppJ paper, because then we can get people to cite that paper. And so this ability to create artifacts that from the top down look like normal journal papers, but from the editor and reader's point of view is just a description of the software, works really well. Now, what this policy doesn't do is tell us anything about the usefulness of the software. We don't review the software. We're not set up to do that. We peer review the paper and its content, but we don't go and run the software, check it installs and so on. We'd like to encourage people to do a good job of those things. So what we've done is we've partnered with the Journal of Open Source Software, which was founded by an ex-astronomer who's now at GitHub, Arvin Smith. And JOSS is designed to be low-effort software review. So you submit your open source package via GitHub to JOSS with about a paragraph of description, sometimes a little bit more. And all the review takes place in the open, and they do things like check the documentation, check that it runs, see whether it's test driven, and so on. So they're actually doing a review of the software. You could submit the same paper to the same piece of software to our journals and to JOSS. The two coordinate. We actually give JOSS a little bit of money. And when your paper is published in AppJ, you'll see a note, a badge in the context of our earlier conversation that says software is reviewed by the Journal of Open Source Software. So we're creating these citable objects for software. Now we need to make sure people cite them. And in general, it's really important to realize that policies like this only work when they're enforced. So it's one thing to create citable objects for software. It's another to make sure that people actually cite software. And I think one of the things that's best about our journals is this bit is an advert, because these two people are excellent. This is Greg Schwartz and Gus Mensch, who are our data editors. They look at and substantially read about 3/4 of the papers submitted to our journal. And one of the things that they do is, before an editor like me gets anywhere near it, they will look for software that needs citation. And when I see the paper for the first time as an editor, before I write to the author, I get a little note that says Gus and Greg say they need to cite AstroPy, or they've used this software package which isn't cited, or so on. What this means is, at the moment that the authors are most vulnerable to suggestion, the point where I say, if you do these 3 things, then I will accept your paper, we say, please cite the software properly. And so this has led to an ecosystem in which people are getting better at citing software, and those who write software have got these artifacts that they can cite. I think this is a crucial piece, and it's a really good example of what I'm talking about when I talk about using the existing system to further the goals that many of us in this meeting share. So that sounds good. Cheers. But you might ask, what about data? Which might confuse me. But we've talked about software, but journals, we've just heard, should make sure that people are also distributing the data that goes with their paper. If we want reproducible research, we need to know what data people have used to create that wonderful plot, or so on. And lots of people have thought about this. There's been a lot of effort. Monthly notices, for example, insist on a data availability statement, and they provide some sample examples, which include the statement that the gold standard is to say that the data underlying this article is available at this DOI. And this is a good start. It makes people at least think about where their data is when they're submitting. I've certainly had the experience of co-authors coming back and saying, oh, well, paper has been held up because we didn't put a data statement in. What are we doing with the data? And only having that conversation about where to put the data then. You can write anything you like, though, and one of their examples is the data underlying this article will be shared on reasonable request to the corresponding author, which I think means go away. This is not a policy, and I don't think there's been any journal brave enough in our world, our field, to insist that data is made available. But at least there's a statement. However, I think there's a bigger problem with this sort of approach, and that is that, as far as I know, no one is going to check that that data is actually useful. That would be an enormous task for the journal, equivalent to us going and reviewing all the software, which we didn't do. If I say the data under this article are available at this DOI, you might check that the DOI works, but to check that that's the data that actually produced the figures in the paper requires a huge amount of work, and possibly digging into code or notebooks or all the rest of it. So this is quite a big bar. However, there's a bunch of people in astronomy who've thought a lot about how to do long-term data storage of packets of data points that have specific outcomes. And those people are the large institutional archives. And so one approach we've taken is not to reinvent the wheel, but to work with the archive. So if you go to submit a AAS paper now, you will see a set of questions on the form, which include, for example, did you use IPAC data? So if you use data from IRSA, the NASA Exoplanet Archive, NED, ExoFOP, or the KOA, then you should say yes. And if you say yes, you have to give us the DOI from IPAC. We have similar collaborations with MAST. There's a great paper that explains exactly what we've done and why we've done it. MAST will let you, if you've used any data from that archive, so that's all Hubble data, for example, things like TESS, you could create what's called a high-level science product on MAST, which is a collection of data with your own metadata on top of it, which you can then give us a DOI to. And the archives will maintain that. The journals will just provide the link. So I think this is a really nice example of collaboration, so that the journals get to do the thing that they're good at, and the archives get to do the thing that they're good at. I'd love to expand the list of places that we're collaborating with in this way. It's easy for us to do that. Again, we're reusing the existing system to give publicity to good practice. Another way we can do this is to find collaborations where we can publish papers to recognize work that would otherwise go unnoticed. I'm a member of the Vera Rubin Observatory collaboration. We're getting very excited about our new survey telescope. And we're having a very polite and quite formal argument about the cadence that the survey should use as the telescope moves across the sky. As a result, large numbers of groups wrote white papers that argued that for their science case, what the cadence should be, work that required an awful lot of technical work, but doesn't really produce a scientific result. We produced a special issue of the AppJ supplements, which published lots of those white papers. They're peer-reviewed like anything else, but we waived the requirement that you need a science result. So these are now citable objects, and they're beginning to pick up citations from people interested in the work that was done. This is work that would normally be banished into the grey literature. We will take lots of your grey literature and find ways to publish it because we don't care that much about our impact factor. I think I'm allowed to say that. Incidentally, as we're publishing all of these things, I want to point out that we as a community are gathering evidence about whether articles that do a good job on openness and reproducibility do get more attention. I haven't seen much systematic work on this. I haven't had time to do some myself. There's a great data set from Geert Barenston, who looked at the first few years of Kepler, which was a closed data set available initially to the Kepler team themselves, and K2, which is the extended mission, which had slightly different characteristics, but worked in a completely open way as a condition of its funding for an extension. And in the first couple of years, not only are there more K2 papers than Kepler papers, but Geert pointed out, this is 3 or 4 years old now, that there were more unique authors and more unique institutions. A broader range of people were using the open data. Well, I guess that kind of makes sense, but he was even able to show that the data was being used by younger people. And so by making things open in the journal, at least for this example, and making open tools and data available, we've shifted who is able to publish. I'd love to see a more detailed analysis of this across all of our journals, because we've got ADS, we can do this. The data is all sitting there. Speaking of who can publish, I want to finish by talking about one project that's really dear to my heart, because through my citizen science work and through other experiences, it's become clear to me that the barrier to publishing a paper is high. It's high for some projects. You know, maybe that negative result will never reach the point that you'd want to write an AppJ paper about it. But it's also high for some people. I ran grad admissions in Oxford for astrophysics for many years and got sick of reading references that said I did this brilliant project with this excellent excellent undergrad, and just as soon as I get time, we'll turn it into a paper. The solution to some of these things is research notes of the AAS, which is a short moderated, not peer-reviewed, as in I and occasionally some friends read the submissions rather than doing formal review, journal which has no bar to notability. So we don't assess whether your research is interesting or not. And we've published all sorts of things. We get topical notes. Some of the very first were about Oumuamua, which had just come past. I'm bracing myself for a Gaia deluge with the data release in a few months' time, or next month, isn't it? We've had some topical things. There's Gaia. We've had stuff published just for posterity. This was a beautiful spectrum of Orion, which is the last spectrum taken by the Caltech Submillimeter Observatory. We've had non-detections. We deliberately encourage those. And we've had these student projects. So if you are working with summer students or RUE students this summer, please encourage them to aim to write a 1 or 2 page research note at the end of their at the end of their experience. Research notes have greatly diversified the group of people who are able to contribute to formal academic publishing in astronomy, and they're on ADS alongside all the journals. I am just about out of time, so let me conclude as follows. The way our ecosystem has evolved means that the main astronomical journals and our control of them offer the opportunity to reward change that encourages reproducibility. And that sometimes, while it's fun to talk about burning the system down, which I would love to do, I think we lose sight of the fact that incremental change is both possible and be highly impactful, particularly for individuals who are applying for jobs and building careers right now. And that policy isn't enough. We need to enforce things, which needs resources, but we're the customers of the journals and they're owned by our societies. So encouraging journals to put resources the way of reproducibility seems like a good idea. And if we're strong enough and there are enough of us, this could become the main way in which the journals compete with each other. And then we'll have a race to try and see which are best at encouraging reproducibility. If you'd like to talk to me about any of these ideas, I am on the Slack, I am on the email, but most of all, as ever, I am on Twitter, and I'll happily take any questions we've got time for. Thanks.
Okay, thank you very much, Chris, for this very cool talk. We've already got a couple of questions in Slack, so I'll dive in and start asking you them. So first up, Sundar Srinivasan says, thanks for bringing up the reasonable request thing, which he's seen not only in a few published papers, but also some telescopes and observatories claim to have public archives, but then it turns out to be, send an email to some person. Do you think there's anything we can do in those sorts of situations?
Yeah, it's obviously frustrating. I think my manifesto would be threefold. So first of all, I think it would go a long way to demonstrate that papers with open data or where the data access statement is broader, or where there's a link to MAST or IPAC or one of the other established archives, get more citations. We all know there are problems with citations, but it's at least a metric we can measure. I think showing that doing the right thing is good would be a good thing. Second thing is, we talked about badging in the previous talk. There is, I think it's Goodhart's law, which is that any metric adopted as a target instantly ceases to be useful as a metric. But I do think we could do what we've done with the JOS example and put a badge on papers that say reproducible. We'd have to argue about how to assess that, but I think that's a reasonable thing to do. And then the final stage would be to move to a system in which journals insisted on proper data archiving and had the resources to check. But my sense is that will only happen when the community is nearly unanimous that that's the right thing to do, or funders become unanimous that that's the right thing to do. At the minute, the culture of our field is such that it's fine to keep your data on your own hard drive, at least some of the time.
Cool. And I will ask another question very quickly, which is from Alessandro Ederopite, which is, as a data provider, how do I attach a DOI to the data sets that I'm publishing?
I will put some guides in Slack. I think that's where there are a couple of quite well-written examples of that, but most of the big archives make that pretty easy. One answer, unless you've got a very large data set, is that if you put it on Zenodo, Zenodo will generate a DOI for you. That comes with, it's not so much creating a link, it's also there's some institutional commitment to making that a long-term link so that we avoid link rot. But I will put some tutorials in Slack as soon as we finish talking.
Cool. Thank you very much, and thanks again for your excellent talk. Again, if you could take a look at Slack and answer other questions that are coming up, because there's a lot of good, interesting questions there. That would be great.